Hello everyone. In this video, Professor Albert explains to our granny the concept of slope of a line. Granny asks, I remember you talking about this thing called differentiation to calculate gradients in the gradient descent discussion. What exactly is this? Albert says, to understand differentiation, you first need to understand the concept of slope. Did you ever wonder why a line is always represented by the below equation y equal to mx plus c? This is a line that we have obtained when we were trying to solve your daughter's problem, where we are trying to predict the price of a house based on area. Did you ever think about this? Did you guys ever think about this? Why is the equation of a line y equal to mx plus c? Granny says, yeah, I did think about it, but then I just assumed it. It is just an equation that connects input and output. Nothing more, nothing less. Albert says, not really. It's not just an equation. There is a beautiful logic behind that equation. That logic is nothing but the slope of the line. So what is this slope? Granny asks. Albert says, let us go back to our mountain descent example. Let us say below scatter plot represents the distances you have covered after different time intervals. After half an hour, you covered 0.25 kilometers. After 2 hours, you covered 1 kilometer. And you can plot a line. And you can see that the C value in this case will be 0 because it is passing through what we call as origin, which is you have not covered any distance at time 0. You didn't have any head start. Now, Albert says, looking at this data, can you tell me how much distance you would have covered after 1.25 hours, which is 75 minutes? Granny takes some time and she then says 0.625 kilometers. Albert is shocked. How did you come up with the number? Granny says, well, I observed a pattern between distance and time, and I noticed that I just need to half the value of time to find out the distance covered till that time. Granny is intelligent, right? She has seen that whenever the time is, let us say 0.5, the distance is 0.25. When the time is 1 hour, the distance is 0.5. When the time is 1.5, it's 0.75, 2, 1, 2.5, 1.25. And then that's how she said, because the time that you have provided to me is 1.25 hours, I just halved it and I got the value as 0.625. Albert says your answer is correct. What you just calculated is nothing but the slope of a line. The way you quantify the relationship between the x-axis value and the y-axis value is nothing but slope. Slope value explains how the value on y-axis varies with the value on x-axis. And can we say this equation y equal to half x represents this line? The half representing slope. And we calculate slope, we define slope as the ratio of difference in y coordinate values by difference in x coordinate values. So what are these coordinates? Let us take an example. Take these 2 points. These 2 points are represented by these values. So this 2 represents, that is the x-axis value. That is nothing but the time grandma has taken. And 1 represents nothing but the distance she has covered. And similarly, for this point, 1.5 is nothing but the time she has taken. 0.75 is nothing but the distance she has covered. And y1 is represented by 0.75. x1 is represented by 1 point. We are just saying it is the first point that we are considering. x2, y2. So x2 is represented by 2 and y2 is represented by 1. So we are taking 2 points. You can take any 2 points. I just randomly taken these 2 points on this line. Now, how do we calculate slope is this. We subtract the values of y coordinates and we subtract the values of x coordinates and then we take a ratio. So a slope is telling us how the y value increases when x value is changing. It quantifies that variance in y whenever x is varying. Granny says, okay, understand the mathematical importance of it, but what exactly is its importance? Albert says, knowing the slope of a line lets you find out the y value for any x value. Slope for every point on the line remains the same. If you notice, if you look at our data, right, all the points on the line will have the same slope, which is 1 by 2. Let us take an example. Say you want to know how much distance you will travel in 3 hours. You have this data so far, and you want to know how much distance will you travel in 3 hours. That data point is not there, but you have the line, and you know that there is a point that is going to lie on that line, and that point is going to correspond to these x coordinate values and y coordinate values. X coordinate value is nothing but 3 hours, that's what you said, and the y coordinate for 3 is 1.5, right? And why? How can we say it is 1.5? Because every point on this line should honor this relationship. Y equal to 1 by 2 into 3. The slope of every point remains the same. It should always be 1 by 2. Right? That's how I predicted that you are going to travel 1.5 kilometer after 3 hours. And it says, nice. Mathematics makes sense, and also the real world application of slope makes sense. Then she says, I understand the significance of m value. What about the c value in the below equation? When do we get that? Y equal to mx is the value that we obtained, but you said c value is 0 because we're starting with, I'm not taking any steps at the start of the time when t is equal to 0. Albert says, in most of the scenarios, in real world scenarios, the line might not be so perfect. It might not be starting at absolute 0. Y value need not be 0, as you can see here, as you can see with this yellow line. The c parameter represents this mathematical adjustment. And that's the reason why we generally represent the equation of a line with y equal to mx plus c, because it may not be perfect, it might not always start at the origin. Randy says, nice. Now I understand why the equation of a line is represented in this format. Albert says, awesome. Now you are ready to understand differentiation, which we'll be covering in a later video. In this video, we have understood the concept of slope of a line, where slope quantifies the change in output for a unit change in input. Input is on the x-axis and output is on the y-axis, and all the data points are connected by a line. Thanks for watching.